Hello. Today we're going to talk about how to approach this famous equality e to the imaginary theta equal to I sine theta plus cosine theta using symbol calculus method. In the previous video I showed you guys how to approach this problem using direct way of Maclaurin series and how to use comparative method in order to come up with a proving resolution. So today we're going to apply this in a much simpler way. It's rather very short, and I think it's very powerful. So let's start with, first we look on the right side of the equation. We can let this whole functions equal to y. So let's call y equal to I sine theta plus cosine theta. Okay. So maybe we can try some ways to make the minus sign appear, because you know that I have something to deal with the minus 1, because I squared is minus 1. So let's take a derivative of both sides. So you would have dy d theta equal to I cosine theta minus sine theta. Okay? And you can say that equal to y prime. Okay? So if you pay attention a little bit to the sign, you can see here, in front of the sine theta, you have minus 1 for the y prime. But for the y, you have the I in front of the sine theta. So and for the cosine theta, you have I in front of the cosine theta for the y prime, and for the y only, you have only cosine theta. So it means that it seems like from to get I to the y prime, you only times I on this function. So it appears that y prime is equal to I y. So how interesting! But this tool can get us to a very direct way of figuring out the equalities right here. So we have dy d theta, therefore equal to yi. So it appears that we have a differential equation. It turns out to be separable. So I, you can think of that as a constant. It's an imaginary number. And we pull everything on one side. So you have dy over I equals to I d theta. Okay, so now how do we do this? Well, we antiderivative on both sides. So let's antiderivative on both sides. Okay, so this appears to be ln absolute value of y equal to I theta plus c. Alright. So in order to figure out y, we probably times exponential on both sides by e. So let's try that and see what happens. So let's try this one. Okay. So let's times that, e that to this. So what do we have? We would have the absolute value of y would equal to e plus c. We can say that's some k e theta, or you can say just goes, because k can be anything. It is a constant. So you go ahead and get rid of this absolute value. Okay, because k can evaluate by using initial value, and in fact we are going to use initial value in order to figure out the k, what k is going to be. So let's try theta to be 0. Okay, that's we say that theta go from 0 to 2 pi. So that's is our interval. Let's start with the initial value. So we have the initial value theta equal to 0. We plug in here sine 0, that's 0. Cosine theta 0, that's 1. Here e to the I theta. Theta is 0, 0 times I, that's 0, e to the 0, that's 1. So you have 1 equal to 0 plus 1. So it seems like we only need k. So put it here, y. Initially, we said that y equal to I sine theta plus cosine theta, right? And we proved that by initial value, we said that ei0, that's just 1. In here is 1 as well. So therefore, y is 1. Y is 1, e to the I theta, e to the I0, that's 1. So you have 1 equal to k times 1. Therefore, k equal to 1. Therefore, you would have y equal to e to the I theta. And here, you have the connection. Therefore, the equality is set. Okay, so e I theta, therefore, equal to I times sine theta plus cosine theta. Okay. Alright, thank you very much. This is a very useful way of manipulating the interaction between differentiation, and here you probably apply some separable equation and figure out the solution using the initial values, and it's a very powerful way in coming to understand this this equality. Thank you very much for watching this video, and please subscribe and tune in to our YouTube channel for more interesting mathematics problems. Thank you very much.